Hello everyone, in this video we're going to explore topic 10.3, the n-term test for divergence. Alright, theorem 10.3a. Limit of the n-term of a convergent series. If the sum of a sub n when n goes from 1 to infinity converges, then limit of a sub n when n approaches infinity equals 0. But the converse of this theorem is not true, which means if you have limit of a sub n when n approaches infinity equals to 0, then the sum of a sub n when n goes from 1 to infinity, this one is wrong. So be careful, okay? So keep this one in mind, which means unknown. Now, let's move on to the important theorem for this lesson, n-term test for divergence. If limit of a sub n when n approaches infinity not equal to 0, then the sum of a sub n when n goes from 1 to infinity diverges. Alright, so keep that one in mind. Now, let's take a look at the first example. Using the n-term test for divergence, determine the convergence or divergence of each series. Question A. The sum of n over n plus 1 when n goes from 0 to infinity. Alright, so we're going to use n-term test for divergence, right? So we're going to take limit of n over n plus 1 when n approaches infinity, right? It's going to be right here. Alright, so when n approaches infinity, n grows faster than 1, right? So we can rewrite this one as limit of n over n. When n approaches infinity, we just ignore 1, right? So this one equals 1, not equal to 0, right? So by the n-term test for divergence, this series divergence, right? Now question B. We have limit of 1 plus 3 to the n over 2 to the n when n approaches infinity equals. This guy right here grows faster than this guy, right? So we just ignore 1, right? So we have limit of 3 to the n over 2 to the n when n approaches infinity. It's going to be limit of 3 over 2 to the n when n approaches infinity, right? And it's going to be infinity, right? So by the n-terms test for divergence, this guy's divergence, right? Now we have another way to do this one. We can use geometric series, right? So the common ratio is 3 over 2, which is greater than 1. Then by the geometric series, the series divergent, right? Now question C. We have limit of 1 over n when n approaches infinity equals 0, right? This one is inconclusive, right? Now question D. We have limit of n cubed over n factorial when n approaches infinity. Now remember, this one is exponential function. This one is factorial function. Factorial grows significantly faster than exponential function, right? So the bottom is much larger than the top, and then this one becomes 0, right? So you can say this one is inconclusive, right? Now let's take a look at the example number 2. For each series below, decide whether it converges or diverges and explain your reasoning. We have limit of 3 minus 2n over 5n plus 1 when n approaches infinity. This guy grows faster than this guy, right? This guy grows faster than this guy, right? So we can ignore 3 and 1 right here, right? So we have limit n approaches infinity of -2 and over 5n, right? N and n cancel out, so it's going to be -2 over 5, which is not equal to 0, right? So by the n term test for divergence, this series diverges, right? Now question 2. We have limit of 3 to the n plus 1 over 5 to the n when n approaches infinity, right? So it's going to be limit of 3 times 3 to the n over 5 to the n when n approaches infinity. And it's going to be limit of 3 times 3 over 5 to the n when n approaches infinity, right? Now, when n approaches infinity and this fraction is greater than 0, less than 1, so it becomes 0, right? 0 times 3 is going to be 0, right? Now, by the n term test, it is inconclusive, right? We can use geometry series to determine if the series convergent or divergent. Now, we look at this one right here. This guy actually geometry series, right? Where common ratio is 3 over 5, right? Which is less than 1, right? So then the series convergence, right? Now by the formula we have a over 1 minus r, right? A is the first term. The first term when n equals 1. You substitute over here, you have 9 over 5, right? Over 1 minus 3 over 5. Now, it's going to be 9 over 5 over 2 over 5. Multiply the top bottom by 5. So the answer is 9 over 2. So the series convergent to this number. Now, question 3. We're going to take limit of 2n over square root of n squared plus 1 when n approaches infinity. It's going to be limit of 2n over n squared grows faster than 1. We can ignore this one, right? So we only have square root of n squared when n approaches infinity. And it's going to be limit of 2n over absolute value of n when n approaches infinity. Now, when n approaches infinity, this guy always positive, right? So you can remove the absolute value side, right? So it could be limit of 2n over n when n approaches infinity. N and n cancel out, so it could be 2, right? So by the n term test, this series diverges, right? Now, question 4. We have limit of e to the n plus 1 over pi to the n when n approaches infinity, right? So it's going to be limit of e times e over pi to the n when n approaches infinity, right? Now this guy actually equals 0, right? Because e equals 2.171828, etc. And pi is going to be 3.14 something, right? So the top is less than the bottom. When n approaches infinity, this guy approaches 0. 0 times e is going to be 0, right? Now, so then we can say that this guy is inconclusive, right? We can use the geometric series to determine if this one convergent or divergent, right? So we look at this one right here. The common ratio is e over pi, right? And the first term is e times e over pi, right? So we have the formula a over 1 minus r, right? This guy right here less than 1. So the series converges, right? So it could be e squared over pi over 1 minus e over pi. So it could be e squared over pi minus e over pi. Multiply the top bottom by pi. So it could be e squared over pi minus e. Alright, so finally the series converges to this number, right? Now question 5. We have limit of 7 to the n plus 1 over 7 to the n plus 1 when n approaches infinity. Now when n approaches infinity, this guy grows faster than this guy, right? We can ignore 1, right? So we have limit of 7 to the n over. You cannot say you're gonna ignore 1 right here, be careful, okay? You only ignore the 1 on the top, that's it, right? This one is addition, this one is the multiplication, right? So you have 7 to the n times 7 when n approaches infinity, right? So it's gonna be 1 over 7, right? Because this one cancel out, right? And this one not equal to 0, right? So we can say this series diverges by the n-term test. Now question 6, we have limit of 5 times 5 over 2 to the n when n approaches infinity. Now look at the fraction right here, the top greater than the bottom. So when n approaches infinity, this guy approaches infinity, so this guy equals infinity, right? So by the n-term test, the series diverges, right? Now we have a second way to do this one. Observe that this guy actually geometric series, right? With the common ratio equals 5 over 2, right? But 5 over 2 is greater than 1, right? So by the geometric series, this series diverges, right? Because the common ratio is greater than 1, right? Now let's take a look at example number 3. For each series below, decide whether it converges or diverges and explain your reasoning. The n-term test can be used to determine divergence for which of the following series. Alright, so we're going to take limit of sine 2n when n approaches infinity. This guy does not exist. You know that the sine function is going to be oscillating between 1 and negative 1, right? So when n approaches infinity, this guy does not exist, right? So it tells us that this guy diverges, right? Now, question 2, we have limit of 2 plus 3 over n when n approaches infinity, right? This guy approaches 0, so it's going to be 2 not equal to 0, right? So this one diverges, right, by the n-term test, right? Number 3, we have limit of n cubed plus 1 over n squared when n approaches infinity. We can ignore 1, right, because this guy grows faster than this guy, right? So we have limit of n cubed over n squared when n approaches infinity, right? We're going to simplify this one, so it could be limit of n when n approaches infinity, and it's going to be infinity, right? So this series diverges, right, by the n-terms test. So the final answer must be D. Now question B, we still use the n-terms test, right? So we have limit of natural log of n minus 1 over n when n approaches infinity. It's going to be limit of L and up. When n approaches infinity, this guy grows faster than this guy, right? So we have n over n. We just ignore negative 1, right? When n approaches infinity, and this could be limit of ln of 1, right? When n approaches infinity. So it could be ln of 1 equals 0, right? So it could be 0. And this one is inconclusive, right? Now question B, we have limit of 3n minus 2n squared over 5n squared when n approaches infinity. Now when n approaches infinity, this guy right here grows faster than this guy, right? So we can ignore this guy, right? So we have limit of negative 2n squared over 5n squared when n approaches infinity, right? N squared cancel out, so this could be negative 2 over 5, not equal to 0, right? So by n term test, this guy diverges, right? Now, number 3, we have limit of 3 times 5 over 4 to the n when n approaches infinity. Alright, look at the fraction right here, 5 greater than 4. So when n approaches infinity, this guy approaches infinity, right? So by n term test, this one diverges, right? Now we have the second way to do this one. We're going to use geometry series where the common ratio is 5 over 4 greater than 1. So then this one still diverges, right? Now go back to this question. We need to determine the divergence, right? So only B. Correct, right? Now example number 4. If a sub n equals cosine of pi over 2n for n equals 1, 2, 3, etc. Which of the following about the sum of a sub n when n goes from 1 to infinity must be true, right? Now we can take this limit, right? It's the same thing as limit of cosine of pi over 2n when n approaches infinity, right? So then this guy becomes 0, right? So it could be limit of cosine of 0, right? When n approaches infinity, cosine of 0 equals 1, right? This guy not equal to 0, right? So by the n term test, the series diverges, right? So the answer must be C. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand